Okay, so let's do this question. Now if you see over here, this matrix, okay, the middle elements are the same, isn't it? So this matrix which is given to you, okay, we can just take this 20, 25 outside and we can multiply it with the identity matrix because all the elements present here are 0 and the middle elements are the same. Okay, so I can write this matrix as 20, 25, where 2025 is a scalar, isn't it? Okay, 2025 is a scalar and we are multiplying it with the identity matrix. Identity matrix, the diagonal will be equal to 1. Okay, isn't it? So we have just taken 2025 outside the matrix because we know 2025 is a scalar. Okay, now if you remember the identity, that is A into adjoint of A. Okay, do you remember what is A into adjoint of A? Yes, we know A into adjoint of A is equal to determinant of A into I, isn't it? So now if you just compare here this 2025, we have written it like this and we said that this is equal to A into adjoint of A, and we know according to our identity A into adjoint of A is equal to determinant of A into identity matrix. Okay, so now if you see over here, if you compare both RHS and LHS, what is determinant of A from here? Yes, it is determinant of A is equal to 2025 if you compare the LHS and RHS. Okay. So we have found, we need to find determinant A plus determinant of adjoint A. So we found determinant of A is equal to 2025. Now to find determinant of adjoint A, we know a property of determinants, that is determinant of adjoint of A is equal to determinant A raised to n minus 1, where n is the order of the matrix. Okay, now if you see over here, this is a 3 by 3 matrix, so we can just directly substitute it over here. So determinant of adjoint A is equal to, okay, determinant A, what did we find? It is equal to 2025 the whole raised to n minus 1. Here the value of n is equal to 3, where n is the order of the matrix. So 2025 the whole raised to 3 minus 1, which is equal to 2025 the whole square. Okay, so now in our question there, determinant A is equal to what? It is equal to 2025 plus determinant of adjoint of A. What did we find? We found it equal to 2025 square. Okay, see the options. Option A is 1, B is 2025 plus 1, option C is 2025 square plus 45, and if you see option D is 2025 plus 2025 the whole square. Okay, so here option D is the correct answer. I hope it is clear. So now let's move on to our second question. Okay, in the question it says, assume x, y, z, w and p are matrices of the order 2 cross n, 3 cross k, 2 cross p, n cross 3 and p cross k respectively. Then the restrictions on n, k and p so that py plus wy will be defined are. Okay, so here if you see over here, a few matrices are given, x, y, z, w and p, and the order of the matrices are given. Okay, now we need to find the values of n, k and p such that the values should agree with this condition given to you. Okay, now in order to do this question, here we are using a concept of matrix multiplication. Okay, if you remember. Now, when can we multiply two matrices? Yes, we can multiply the two matrices. Let us consider matrix A of order n cross n and B of n cross k. Okay, so if the column of the first and the row of the second, okay, they are equal, then only we can multiply two matrices, and whatever the result, okay, the resultant matrix we will be getting the row of the first and the column of the second. Okay, that is m cross k will be the order of the new matrix that we will be getting when we multiply. Okay, the same concept we are using over here. Okay, so let us consider P, which is of the order P cross K, which is multiplied with Y. Okay, so Y is of the order 3 cross K. Okay, so now if you see, matrix multiplication is possible if this K is equal to 3, isn't it? Okay, we said So from here I can write K is equal to 3. Okay. Now from here we can say that the resultant value, okay, or the new matrix that we will be getting when we multiply these two matrices will be having the order P cross K. Okay. The second matrix, which is WY. W is of the order N cross 3 and Y is of the order 3 cross K. Okay. Now if you see here, this value and this value, both of them are equal, which means that matrix multiplication is possible. Okay, and whatever the resultant matrix we will be getting, it will be of the order N cross K. Okay, so now in the question, now what are they doing? They are adding these two resultant matrices we are getting, that is Py plus Wy. Okay, so basically we are doing Py, which is of the order P cross K, plus we are adding Wy, which is of the order N cross K. Okay, now just think. Okay, we have learned that we can add two matrices. Both the matrices are having the same order, isn't it? Okay. Here this example 1, 2, 3 and 4, which is of the order 2 cross 2. Here also 1, 2, 3, 4, which is of the order 2 cross 2. Here if you see, the order of both of them are same. So basically here the concept is that if we want to add the two matrices, the order of both of them should be the same, which means that this P and N, okay, we already saw that K and K, the value of K was equal to 3, so both of them are equal. So from here, since matrix addition is possible only if the orders are same, so from here we can say that P is equal to N. Okay, isn't it? If only P is equal to N, we can add these two matrices, okay, if they are the same. So from here we found that the value of K is equal to 3 and P is equal to N. Okay, and now if you see your options, option number A. Okay, option number A is the value of K is equal to 3 and P is equal to N. Okay, so option A is the correct answer over here. Okay, I hope it is clear. Third question is the interval in which the function f defined by f of x is equal to e raised to x is strictly increasing. Okay, so this is the question. So now we know, in order to find strictly increasing, first of all, let us take the function e raised to x. We know the differentiation of e raised to x is equal to e raised to x itself. Okay, and we need to prove that it is given that the function e raised to x is strictly increasing, and we need to find the intervals in which this function is increasing. Okay, so now in order to do this question, we already know that the e raised to x function is increasing. Okay, now if you see in your textbook, that is page number 172. Okay, that is in your old NCERT. You can just comment what is the page number in the new NCERT. You can see the graph of the exponential function e raised to x. Okay, now if you just observe this graph, it is starting from minus infinity and it is going and going and going up till the positive infinity. Okay, it is basically strictly increasing. Okay, there is no disruption, no discontinuity. It starts from negative infinity and goes up till positive infinity. Okay, if you see the graph of the exponential function. Okay, so basically what will be the interval in which e raised to x will be lying? Yes, it will be lying in the open interval minus infinity comma infinity. Okay, now why am I using open interval? Because infinity is something which we cannot define. Okay, we cannot bound it inside a particular closed interval. Minus infinity to infinity. Okay, so now if you see in the options, option number C. Okay, option number C, minus infinity to infinity is the correct answer. Okay, so I hope it is clear. The fourth question is, if A and B are non-singular matrices of same order with determinant A is equal to 5, then find the value of determinant of B inverse ABB whole square. Okay, so this is also a very simple question. Now if you see in the question, it is already given that A and B are non-singular, and we know that inverse of a matrix exists only if both the matrices are non-singular matrix. Non-singular means determinant of A is not equal to 0. Okay, so now if you see over here, we can just separate out this determinant values. Okay, so if you we can write it as determinant of B inverse into determinant of A into determinant of B, the whole square. Okay, we know this is a property of determinant. If it is determinant of A into B, if you remember, determinant of A into B can be written as determinant of A into determinant of B, isn't it? Okay, this same property we are using. Now, here we are using another property. We have learned that determinant of A inverse. Okay, determinant of A inverse is equal to what? 1 by determinant of A, isn't it? Okay, same property we are using over here. So instead of this determinant of B, the whole inverse, I can write it as 1 by determinant of B. Okay, into determinant of A into determinant of B. Okay, and the square is present over here. Okay, now if you see over here, this determinant of B cancels, and what is left with you? You have been left with determinant of A, the whole square. Okay, and now if you see in the question, determinant of A, the value is given which is equal to 5. Okay, so just substitute the value. Determinant of A is equal to 5, so you can directly substitute. So you will be getting the answer as 5 square. Okay, you see your options. Option number B. Okay, option B is 5 square, so option B is the correct answer. Okay, so I hope it is clear. Now let's move on to the fifth question. The question is the value of n such that the differential equation x raised to n dy by dx is equal to y into log y minus log x plus 1, where x belongs to real numbers, is homogeneous is. Okay, you see in the question it is given that this differential equation is a homogeneous differential equation. Okay, now in order to do this question, you need to know the definition of homogeneous differential. Okay, we say that differential equation is homogeneous if it can be written as f of lambda x comma lambda y is equal to lambda raised to 0 f of xy. Okay, you have learned this definition, isn't it? Now if you see, differential equation means a homogeneous differential equation means the powers of x and y should be the same. Okay, now if you see dy by dx is equal to y into log y minus log x plus 1. So first of all, what we can do is, let us bring this x raised to n towards the RHS side. So we can write dy by dx is equal to y by x raised to n into log y minus log x plus 1. Okay, now just see, now what can we do? Just observe over here, we are having log y minus log x. Okay, you know that log y minus log x, okay, or log a minus log b is equal to log of y by x, isn't it? Okay, we know log a plus log b is equal to log of a into b, but if it is subtraction, that is log a minus log b is equal to log of a by b. When subtraction comes, we have to divide. When it is addition, we have to multiply. Okay, so this identity we are applying over here. So we can write dy by dx is equal to y by x raised to n into log of y by x. Okay, plus now instead of this 1, remember the value of log of e. Okay, log of e is the exponential function is equal to 1. Okay, now if you don't know this, just make a note of it, because this result is used in many places. That is log of e is equal to 1. Okay, so now here instead of this 1, let us substitute log of e. Okay, log e. You see over here, we are having log a plus log b, isn't it? I said when it is subtraction, it will come to division. So if you are given log a plus log b, we can write it as log of a into b will become multiplication. Okay, so the same concept let us use over here. So dy by dx is equal to y by x raised to n into, okay, log of e into y by x. Okay, we have just simplified our differential equation over here. Now that homogeneous differential equation is something we can write it in the form of lambda raised to 0 f of xy. Okay, so you have learned in your classes that in order to show it is a homogeneous function, we have to multiply the equation throughout by lambda, isn't it? So we can write lambda y by lambda x raised to n log of e into lambda y by lambda x. Now if you see over here, lambda will cancel, lambda will cancel. So you will be getting back this same equation such that this lambda will be raised to the power 0. Okay, isn't it? So for a differential equation to have the degree equal to 0, over here y has the power 1. So definitely x also should be having the power 1. Okay, isn't it? Then only we can say it is homogeneous, which is homogeneous means same throughout. Okay, here also y by x, here also the power of y is 1, here also the power of x is equal to 1. So in order to get the degree equal to 0, the power of x should be equal to what? It should be equal to 1. So from here we can say that n is equal to 1. Okay. Now since it is an MCQ question, you don't need to do so much of step. The thing that you should remember over here is for a particular differential equation to be homogeneous, it should be written in the form lambda raised to 0 f of xy. Option number B. Okay, option B is the correct answer. Okay, I hope it is clear. The sixth question is, if the points x1, y1, x2, y2 and x1 plus x2 and y1 plus y2 are collinear, then the value of x1, y2. Okay, now when you see this question, here there are 3 points which are given and it is said that they are collinear. So the first thing that should come to your mind is, whenever 3 points they are given collinear, you should be remembering that the area of the triangle is equal to 0. Okay, and in a determined formula to find the area of the triangle, that is half of x1 y1 1 x2 y2 1 x3 y3 1 to use over here. Okay, so half of, okay, the area of the triangle, that is x1 y1 1 x2 y2 1 x1 plus x2 y1 plus y2 1. Okay, now since it is said they are collinear, is equal to 0. Okay, now so here half this 2, when you take it to the other side, 2 into 0, it will become 0. Okay, so we need to solve only this determinant part. Okay, now just like you do your normal determinant solving, just expand it and solve. Okay, now when we do the expansion, instead of doing it from the row wise, if we take the columns, now if you see here we are having 1 1 1, isn't it? So if we expand the determinant from the column, it will be much more easier. Okay, so plus minus plus, so 1 into x2 into y1 plus y2 minus y2 into x1 plus x2. This into this minus this into this. Okay, minus 1. Okay, this is plus. Okay, if you remember the sign convention, this is plus minus plus minus plus minus plus minus plus. Okay, so whenever you take the 1, okay, don't forget to put the symbols. Okay, don't. So this row and this row cancels. So x1 into y1 plus y2 minus y1 into x1 plus x2, and finally this row cancels. So x1 y2 minus y1 x2. Okay, now after you open the bracket, you will be getting it as x2 y1 minus x1 y2 is equal to 0. Okay, now just take this to the other side, so you will be getting x2 y1 is equal to x1 y2. Okay, and in our question it was asked what is the value of x1 y2. So x1 y2 is equal to x2 y1. Okay, that is your option. Okay, so option A is the correct answer. Okay, the seventh question. The question is, if A is equal to this matrix is a skew symmetric matrix, then the value of A plus B plus C. Okay, it is given that this matrix which is given to you is a skew symmetric matrix, and we know that for a skew symmetric matrix the condition is A is equal to minus of A transpose. Okay, if this matrix A is equal to negative of this A transpose, we can say that this matrix is a skew symmetric matrix. Okay, now without doing anything, from here we can predict the value of A, isn't it? We know that the diagonal of a skew symmetric matrix is always equal to 0. Okay, so this is something which is very important note. Okay, you can just, it is given in your text also, but you can just make a note of it. That is, diagonal of a skew symmetric matrix is equal to 0. Okay, so from here we can say that A is equal to 0. Okay, skew symmetric means A is equal to minus of A transpose. Okay, so now if you just observe over here, here we are having a minus 1. This same, this minus 1, 2, 3, the same thing. We have to change the sign and write it over here. Okay, that is the meaning of skew symmetric. Now if you see here, the towards this side we are having 2 over here. Okay, so this C also will be the negative of it, because minus of A transpose, right? So if this is equal to 2, the value of C will be its transpose. That will be the negative value. Okay, so from here I can say that C is equal to minus 2. If this is 2, C will be equal to minus 2. Okay, now just see over here. Here we are having 1, isn't it? So here if we consider this column, okay, if we consider this, okay, and if we consider this, if you see over here, this here we are having plus 1. So when we go below, we are taking negative value, so it is equal to minus 1. So if here we are having 2, this C will be equal to negative value of it, which is minus 2. So if this value is equal to 3, the value of B will be equal to what? The value of B will be equal to minus of 3, isn't it? But now in the question a minus is already given, so we have to put minus of minus. So minus of minus becomes positive 3. So you will be getting B is equal to 3, isn't it? Now we can just substitute our values over here, isn't it? So A plus B plus C, which means it is 0 plus 3 plus C is minus 2. Okay, so 3 plus minus 2 is equal to what? It is equal to plus 1. Okay, so here the concept that you should remember. First concept is diagonal of a skew-symmetric matrix is equal to 0. So from there we found that A is equal to 0. Now since it is a skew-symmetric matrix, A is equal to minus of A transpose. So whatever values are present below the diagonal, okay, and whatever values which are present above the diagonal, both of them are same, but it will be the negative values of each other. Okay, that is the concept that you should keep in your mind. Okay, so now if you see your options, A is 1. Okay, so option A is the correct answer. Okay, so I hope it is clear. A is equal to half and P of not B is equal to 2 by 3 and P of A intersection B is equal to 1 by 4. Then find the value of A not A by B not B. Okay, so here from the conditional probability, so we know that P of A given B is equal to P of A intersection B by P of B. Okay, now instead of asking P of A given B, they have asked you for P of A not A by A not A given B not B. Okay, that means they are asking you for the complement. Okay, so whatever is being asked to you, just write the formula. Okay, asking for not A, put not A over here and not B. Whatever is the question, just modify the formula in accordance with it. Okay, now here P of not B is given to be 2 by 3. Okay, that we can directly substitute. So P of A not A by B not B is equal to P of A not intersection B not the whole divided by this we can substitute it as 2 by 3. Okay, now we don't know what is the value of this quantity, isn't it? But how can we find the value of P of A not intersection B? Now if you see over here, in 11th we have learned a theorem, the number 1 sets, if you remember, isn't it, which we call it as the De Morgan's law. Okay, if you remember the equation, that is A complement intersection B complement is equal to A union B the whole complement. If we are taking intersection over here, when we take the whole complement of it, it will become union. Okay, the same concept we are applying in the case of probability also. If A naught intersection B naught is equal to, here the intersection will become union. So we can write is equal to A union B the whole complement. Okay, so here also I can change it and write, so P of A union B the whole complement result, that is probability of an event plus probability of that event not happening is equal to 1, isn't it? So from here I can write probability of the event not happening is equal to 1 minus probability of the event. Okay, so the same concept just apply over here. So we will be getting probability of A not given B not is equal to 1 minus probability of A union B. Okay, the whole divided by 2 by 3. Okay, now here our main task is to find the value of probability of A union B. Okay, now we know our relation between union and intersection, isn't it? So we can just apply that formula. We know probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Okay, now you can just substitute the values. Now here, before that, here we have been given probability of not A. In order to find probability of A, what should we do? 1 minus, isn't it? So probability of A is equal to 1 minus 1 by 2, which is 1 by 2 Similarly, probability of B is equal to 1 minus 2 by 3, which is equal to 1 by 3, and we know probability of A intersection B is equal to 1 by 4. Okay, so just substitute the values 1 by 2 plus 1 by 3 minus of 1 by 12. Okay, so just substitute it over here. So 1 minus 7 by 12 the whole divided by 2 by 3. Okay, so now just cross multiply 12 minus 7 by 12 the whole divided by 2 by 3. Okay, 12 minus 7 divided by 2 by 3, which is equal to 5 into 3 by 12 into 2, which is equal to 15 by 24. Okay, now we can cancel it by 3. So here we will be getting 5, here we will be getting 8. Okay, so finally we will be getting our answer as 5 by 8. Okay, so the final answer is 5 by 8. Okay, option number C. Okay, C. Option C is 5 by 8. Okay, so option C is the correct answer. Okay, my question is the value of alpha if the angle between p vector is equal to 2 alpha square I cap minus 3 alpha j cap plus k cap and q vector is equal to I cap plus j cap plus alpha k cap is obtuse is. Okay, now here since you may get confused with this 2 and alpha, that's why I have written instead of alpha capital A. Okay, first of all let us write the formula to find the angle between any two vectors. We know it is cos theta is equal to a vector dot b vector divided by magnitude of a vector into magnitude of b vector. Isn't it? This is the formula to find angle between two vectors. Now just see, in the question it is given that the angle which is formed between these two vectors is obtuse. Now we know. What do you mean by an obtuse angle? Obtuse angle means, let us consider an angle theta. Obtuse angle is the angle which lies between 90 degree and 180 degree, isn't it? Now here we are having cos theta. So let us draw quadrants. This is the first, second, third, fourth. Okay. So since it is said it is an obtuse angle, it means we need to start from uh, 90 degree to 180 degree, which means this quadrant, isn't it? And we know that all silver teacup. Okay, we know that in the second quadrant only sign is positive. Okay, but here it is cos. Okay, which means that in the second quadrant cos theta is negative. Okay, so from here we can say that cos theta is less than 0, isn't it? Negative means what? Negative means definitely it will be less than 0. So I can write cos theta is less than 0. Okay. Now here if you see cos theta is equal to this fellow. Okay. Cos theta is less than 0. Then this fellow is also less than 0. Isn't it? So from here we can say that a vector dot b vector divided by magnitude of a vector into magnitude of b vector is also less than 0. Okay. Now what can we do? Just cross multiply it and this full fellow will cancel off. Okay, so we will be getting a vector dot b vector is less than 0. Okay, now here in place of a vector and b vector it is given p vector and q vector. Okay, so let me just rewrite it. P vector dot q vector is less than 0. Okay, now if you see it is given the dot product of the two vectors is less than 0. Okay, which means we need to find the dot product of these two vectors. Okay, so let us write 2a square I cap minus 3a j cap plus k cap dot I cap plus j cap plus a k cap. Okay, we know when we do dot products I, j, j and k, k. We should multiply. I into I is 1, j into j is 1, k into k is 1. Only the coefficients you need to multiply. Okay, so we will be getting 2a square minus 3a plus a. Isn't it? 2a square minus 3a plus a. Okay, less than 0. Now minus 3a plus a means minus 2a. So 2a square minus 2a is less than 0. Okay, take a 2a common, isn't it? So 2a, here we will be getting a minus 1 less than 0, isn't it? Now if you see over here, we have got a inequality which is less than 0 over here. Now if you remember your wavy curve method that we have learned in the application of derivatives chapter. Okay, when we did our maxima, minima, strictly increasing, decreasing and all. Okay, so first of all the first function is 2a. So just equate it to 0. So 2a is equal to 0. So a is equal to 0 by 2, which is equal to 0. Then similarly a minus 1 is equal to 0. So from here we will be getting a is equal to 1. Okay. So basically the critical points which we are getting over here is 0 and 1. Okay. Now what should we do? Our next step is plot the critical points on a number line. Okay. So if this is the number line, towards this side we are having positive infinity. Towards this side we are having negative infinity. 0 comes over here. 1 is present over here. Okay. Now since we had got a function as positive 2a into a minus 1, we can start from the positive infinite side, come over 1, cut it, then go to 0, again cross it. Okay, we are moving like a wave. Okay, now if you see, what did we actually do? We did a vector dot b vector less than 0. Less than 0 means look where the graph is descending downwards. Okay, so it is descending at between the intervals 0 and 1. Okay, so the value at which 2a into a minus 1 less than 0 is decreasing, or is less than 0 is in between 0 and 1. So from here we can say that the value of a, okay, in the question it is alpha, so we can say that the value of alpha or a, whatever it is, it belongs to the interval 0 comma 1. Okay, so we can say that the value of alpha lies between the open interval 0 and 1. Okay, okay, so I hope it is clear. The 10th question is, if magnitude of vector A is equal to 3, magnitude of vector B is equal to 4, magnitude of A vector plus B vector is equal to 5, then find the value of magnitude of A vector minus B vector. Okay, now when such type of question comes, where there is A plus B and A minus B together, okay, the bullet point that you should remember is add the square of sum of both of them. Okay, that is, first of all, square this A plus B and A minus B, and we should add them. Okay, and just like you do your A plus B the whole square and A minus B the whole square, just expand it. Okay, this is the bullet point. Okay, see, A plus B the whole square, we can write it as magnitude of A square plus magnitude of B square plus twice of magnitude of A into magnitude of B. Okay, plus here also magnitude of A square plus magnitude of B square minus twice of magnitude of A into magnitude of B. Okay, so now if you see, this and this fellow get cancelled, and what is left? A square plus B square, A square plus B square. So we can write it as twice of magnitude of A plus magnitude of B, magnitude of A square, twice of magnitude of A square plus magnitude of B square. Okay, and this is equal to what? Magnitude of A plus magnitude of B the whole square plus A vector minus B vector the whole square. Okay, basically we just expanded this and wrote, and we cancelled it, and we wrote it like this. Okay, now we can just directly substitute the value and find our answer. So twice of magnitude of A vector square means 3 square plus B vector square means 4 square, okay, is equal to this A plus B the whole square. We know A plus B is equal to 5. So 5 square means what? 25 plus magnitude of A vector minus B vector the whole square. Okay, so twice of 9 plus 16 is equal to 25 plus magnitude of A vector minus B vector the whole is equal to 25. Okay, so now 2 times 25 is equal to 50 is equal to 25 plus A vector minus B vector the whole square. So from here what will we be getting? A vector minus B vector the whole square is equal to 50 minus 20, which is equal to what? 25. So from here what can we write? Okay, this is A minus B the whole square. So from here we can write A vector minus B vector is equal to square root of 25, which is equal to what? 5. Okay, so from here we will be getting the answer equal to 5. Okay, which is option number C. Okay, so option C is the correct answer. Okay, so I hope it is clear.